Welcome to chapter 13. We're going to spend a few days on sections 13.1 and 13.2. It's all about trig proofs. I have this quote up here. It's not about the destination, it's about the journey, because I want you to remember as we're going through these that it's not just about getting the right answer. So let's say the answer is tangent of theta. You can't say to me, oh, I got the answer right. How come I lost 3 points? Well, because your journey was wrong. Your proof was wrong. You were missing steps in your work. So remember, you have to show all work as you're doing these questions. It's more about that than about just getting the right answer. Okay? So here we go. I posted the Trig reference sheet. You can either print that or as we go through, you're going to want to make up your own. This is basically a worksheet I would have given you in school on bright paper and said, keep this for the whole entire chapter and do not lose it. You would be allowed to use it on every quiz and test. So this is your reference sheet for the entire chapter. So if you don't have a printer, just this part of the sheet is what you need for this week and next week. And then we use the other sections of the worksheet in the upcoming sections. So on this sheet here, we've got, let's talk about the information we have in front of us. So reciprocal identities, you should know these now. So for example, you know that sine of theta is equal to 1 over cosecant of theta, at least I hope you do. So this is just saying it the other way around, that cosecant of theta is 1 over sine of theta. So those are your reciprocal identities. Your tangent and cotangent ratio identities, this one you knew from when we did our unit circle, and cotangent of theta is 1 over tangent of theta, but we can also just think of it as cosine over sine. So these are all just facts that you should know that are going to be helpful in our proofs. Pythagorean identities are new. And you can look up like where these things come from, but just know that this is a true statement, that cosine squared theta plus sine squared theta is equal to 1. Now, cosine squared theta, that means, okay, what does that mean? That means cosine theta times cosine theta. It's kind of like how x squared is equal to x times x, okay? Common mistake is people think that cosine squared theta is equal to this. That is not true, okay? This, what I just wrote, is actually like saying 2x, which is not the same thing as x squared, okay? So try not to make that mistake. So cosine squared theta is equal to cosine times cosine. I don't think you're going to see this, but just in case, the other way you could write it is cosine of theta squared in parentheses like that. This all means the same thing. Okay, so those three things are equivalent to each other. What's not the same thing, right, does not equal to, it's not the same thing as saying this. Okay, this means you're squaring the theta angle. So remember, theta is the angle measure. So let's say theta was 30. It's like saying cosine of 30 squared. Okay, not the same thing as taking cosine of theta and then squaring that answer. Okay, so not the same thing. We have all of these Pythagorean identities. They come from variations of the Pythagorean theorem. Just know, and we're going to do this in a video. I'm going to clear some space here, that you can take any of these identities and rearrange them. So let's just take this last one, for example. You might see cosecant squared theta minus 1 in a proof. And if you look at this formula, if you rearrange it, you could say that cosecant squared theta minus 1 is equal to cotangent squared theta. So if you saw this in a proof, you could substitute it with this. And that's what we're going to be doing, okay? So just know that these three formulas, you can do all sorts of variations with them and rearrange them for whatever you need. And then the negative angle identities, I don't think we're actually even going to really touch these, but just in case, they are there. All right, so let's get started. We're going to start off this with using theta symbols, but just know that theta could be replaced with anything. Like theta is just a variable in this case. So it could be, sine of x, cosecant x over cotangent x, right? Theta and x are the two most common things to use, but really it could be anything, any variable there. Okay, so what we're trying to do is simplify. We want to take this thing, use all of our knowledge from this sheet and other things that we just might know off the top of our head, and try to simplify the expression. Try to get things to cancel, clean it up a little bit. It should be coming out to like a single trig function. So the answer to this might be sine of theta, or the answer might be cosecant theta, or it might be tangent squared theta, but I'm trying to simplify it to like one thing. And again, you can't just stare at it. If you just stare at this thing, nothing's going to happen. Just start playing around with stuff, and whatever you think in your head, write it down. Make sure that you're putting equal signs in between your steps so I know like where you're going. Draw arrows, either work vertically or horizontally. I'm going to work vertically. So coming down, oh geez. Okay, so coming on to the next step, one suggestion is to take things and turn them into sines and cosines. You don't have to do that. I'm going to show this two different ways and kind of show you how it could be done differently. Let's just go. Okay, so I'm going to keep sine of theta the same, and I'm looking at cosecant of theta, and I'm saying, oh, I know that cosecant of theta is 1 over sine theta. So I'm going to change that, and use a dot for multiplication, to 1 over sine of theta. Now, you could start doing stuff with the denominator of cotangent of theta. You could do this all in one step. You could do it one step at a time. Let's go for it. So let's see. Cotangent of theta, I'm just going to keep going back to the sheet for now. Cotangent of theta, I know that it's cosine theta over sine theta. So I'm going to change that to cosine theta over sine theta. Something important, don't lose those thetas, right? Don't just starting writing cosine sine with no thetas. All right, now we're going to simplify. In the numerator, if I multiply these two fractions, what happens? The signs cancel each other out, and I just get 1, right? On the bottom, what happens here? You can leave it the same. You could change it back to cotangent, but then you're back to where you started. You might want to do a keep, change, flip now at this point. You don't want an improper fraction. A complex fraction. So do a keep, change, flip. So I'm going to keep my numerator the same, change the division to multiplication, and then flip that bottom fraction. 1 times sine theta over cosine theta is just sine theta over cosine theta. Again, notice I'm writing down every little step. And then sine theta over cosine theta is tangent theta. So this is going to equal tangent theta. And now I've gotten it to the simplest thing I could possibly get it to. And that's my final answer, tangent of theta. Now, there was a little bit of an easier way to do this question. I'm going to show it here on the side. So first step, I would have still done the same thing in the numerator, but I would have kept my denominator the same. In the numerator, that all becomes a 1, just like it did before. And from here, you could just go straight to tangent theta. I know that, it's not on our sheet, right? There is nothing that says 1 over cotangent of theta is equal to tangent of theta, but I have this. So it's the same, but kind of opposite of that. So if you have 1 over, you're doing a reciprocal identity that's just not listed on your sheet. So you can do that. Another option is from here. You could have changed cotangent of theta into 1 over tangent theta that was on your sheet. And then you could do a keep, change, flip. And then that would have brought you to that answer. So you can see I just did like 3 different ways of doing this problem. As long as you're showing all your work, you're in good shape. All right, and obviously you can't break any rules. So this is trig proofs. Welcome to them. Let's try another one. Now, as we're trying these, I'm going to encourage you to pause the video and try as much as you can on your own before seeing what I'm going to do. And remember that just because I did it differently doesn't mean that you're wrong. There are many ways to do this question. I might not show all the different ways. It's too time consuming. But if you were thinking something different, just show it to me. Okay, number 2. Pause it and try. See if you can do anything. Now, tangent squared theta. Normally, if I just saw tangent of theta, I might change it into sine over cosine. If you add a square in there, all that does, it adds in squares to this. So even though that's not on your sheet, on your trig reference sheet, you are allowed to do that. So tangent squared theta, I'm going to change it to sine squared theta over cosine squared theta. Secant squared theta, I'm going to change that, it's multiplication here, into 1 over sine squared theta minus 1. Now notice I have no clue where this is going right now. I can't see how this is going to work out. I'm just going for it, and we'll see what happens. Over secant squared theta, might leave it the same. You could change it to 1 over cosine squared theta. I'm actually going to leave it the same for now. Me personally, I don't like to change everything all at once. I like to kind of just deal with one thing at a time before I make it way too complicated for myself. But that's just a personal preference. You might want to go ahead and change that to 1 over cosine squared theta. Okay, it's up to you. So up here in the numerator, I'm noticing that this is multiplication. So with multiplication, I can cancel this numerator and this denominator. So that whole yellow blob, and notice I'm going to put little equal signs on each step so you can kind of see where the next step starts. That whole blob is going to become 1 over cosine squared theta. I still have that minus 1 up in the top over secant squared theta. Okay. Now what jumped out at me, I don't like these fractions. So I'm going to take that yellow fraction there and change it into secant squared theta, right? Because that's the reciprocal identity. I'm just keeping that square there. Make sure the square stays in the right place. I still have that minus 1 over secant squared theta. Please don't tell me that you were thinking about canceling that. You can't do that. As soon as you have that subtraction sign in the top, you can't cancel, right? So what can we do? I can do sharing is caring, right? So I'm going to take this denominator and I'm going to divide it into each thing. Now I'm going to draw an arrow. If this is your paper, you would do the same thing if you run out of space. Draw an arrow so Miss Ingley knows where you're going. And I'm going to show the sharing is caring. Do not do anything in your head. Show every single step. Okay, so all I did was split the fraction into 2. This first fraction then simplifies to 1 minus, this is a reciprocal identity. I can change it to cosine squared theta. And then take a look at this whole thing. Anytime you see 1 with a trig function that's squared, thought bubble should go to your Pythagorean identities. So I'm just going to draw a thought bubble here. You wouldn't actually do this on your proof, but that first trig identity says cosine squared theta plus sine squared theta is equal to 1. If I rearrange this formula, just subtract cosine squared theta to both sides, I would have sine squared theta is equal to 1 minus cosine squared theta. And now I have that 1 minus cosine squared theta. So I can replace that yellow, 1 minus cosine squared theta, with sine squared theta. And this is my final answer. Right, number 3. Again, pause and try it. And then you might want to like unpause after one step, try some more. Unpause after one step, try some more. Okay, on this question, what I saw first, just like the last problem, this jumped out at me. It's the same expression. So I'm going to change that yellow to sine squared theta. I'm going to bring down my secant theta over sine theta. Now I know we say change things right away into sines and cosines. I wouldn't change that secant theta right away because I see something happening here with the sines. With the sines, imagine this was like y over x times x squared. That's basically what this is saying, right? It's something similar to that. What you can do is you can simplify the x squared and the x, right? And that would just simplify to x. So I'm going to do the same thing here with the sines and cosines. One of these, sorry, just the sines. This sine can cancel with one of these. So secant theta times sine theta. Then I'm going to change secant theta into 1 over cosine theta. I'm then going to merge these two fractions together. And then sine theta over cosine theta is tangent theta. Final answer. All right, we're doing 5 examples, so here's number 4. Notice I've changed the thetas into x's, no big deal. If you prefer thetas or you prefer x's one over the other, you can change the problems on the homework, I don't care. Just be consistent and don't lose them. All right, so pause and go ahead and try this one. So I'm going to change the cotangent theta. Again, a suggestion is kind of try to work with sines and cosines. So this would be cosine x over sine x. Just change the cotangent plus sine x. You cannot cancel the sines. You cannot cancel this sign with this sign. Why not? Because of that addition symbol. Okay, so you cannot cancel. So what I can do is I'm going to multiply this. When I multiply that, I get cosine squared x over sine of x plus sine of x. Now this is 2 fractions. How do you add together fractions? You get a common denominator. So this is where it kind of gets a little bit confusing because you don't want to show any more work on this step. So what you would do is you have to do that algebra in your head of getting a common denominator. So I'm multiplying this guy by sine x over sine x to get a common denominator. For me as a teacher, it's helpful to me if you actually show that work. If you do decide to show that work though, I would really love it if you showed it in a different color. This way I can see that this pink step is kind of like your in-between step between, if I call this, this was step 1, this was step 2, and this was step 3, that different color shows to me that it was like step 2.5. It was more of like your algebra in your head than another step in the proof. Okay, so now that we have a common denominator, I'm going to do my next 4th step here. I can keep the denominator the same and add the numerators together. And this is where I find most people get stuck on this very last step. They often want to do sharing is caring, which brings them right back to where they started on step 3. Look at this numerator. Okay, I hope it's jumping out at you. That's the first Pythagorean identity. So cosine squared plus sine squared is equal to 1. So that whole numerator just became a 1. And 1 over sine of x. You could either leave it like this. I would accept either answer. That is fine, or if you took it and wrote this, that's fine. I would accept either one. All right, because you did get it down to a single trig function. Okay. Last one. Number 5. Cosine squared x times tangent squared x plus cosine squared x. Pause and try it. I'm actually going to show you 2 different ways to do this question because I think the skills in each way are good skills to have for future problems. So on the first way that I'm going to do this, I'm going to change everything to sines and cosines like we've been doing. So I'm going to take this tangent squared x, and I'm going to change it to sine squared x over cosine squared x. I'm going to put it in parentheses to help me, plus cosine squared x. The cosines can cancel. So I have sine squared x plus cosine squared x. Again, this is our first Pythagorean identity. It's equal to 1. 1 is the final answer. I want to show you the same exact question a different way. So I'm going to erase. So if you need to copy, pause. So the second way you can do this question, and don't just say, oh, I like the first way better, so I don't even care about the second way, because this is a good skill that you might need in future problems. So the second thing you can do is notice that you have 2 terms here. This is all the first term, and then this is the second term. Notice that these 2 terms have a GCF. The GCF, the thing they have in common, they both have cosine squared x. So I'm going to factor out a common factor of cosine squared x. And when I do that, left over, I have tangent squared x plus 1. Right? So all I did was factor out a GCF. Again, anytime you see a 1 being added or subtracted with a squared trig function, look to your Pythagorean identities. So tangent squared theta plus 1, it's that second Pythagorean identity. It's equal to secant squared theta. So secant squared x times cosine squared x. I'm then going to change secant squared x into 1 over cosine squared x. And then because it's multiplication, those cosines can cancel, and it's equal to 1. This one was a little bit more work, but that skill of factoring, I just wanted you guys to know that factoring is an option in these questions. So you're going to do a 5 or 6 questions on a Google form. Show all your work in your notebook. You're going to upload a PDF of that work so I can take a look at your notation and see what you guys need help with as we move forward with this. Again, it's okay to struggle with this. Don't just say, oh, I didn't get it after 10 seconds and just skip to the next question. Keep trying, try something different. Go on to the next question, then come back to it. Sometimes it might just be better to like completely start over. Just look at the question fresh, okay? But just don't give up, right? Keep working hard at it. And of course there was a joke. I'm just gonna leave that joke there, let you guys read it. It's a goodie. Hope you guys have fun with this. I love them. Have fun with your little puzzles. Bye.